My name is Arturo. I work at MongoDB. Not sure if you're familiar, but we create this very popular database, what's called a NoSQL database. We're going to talk a bit about that in a second. I'm kind of new to Mongo. I've been here for like 6 months. Before Mongo, I was working at a company called Unity Technologies, building the game engine, which was written in C++, but the scripting language was C sharp. So most of the experience I have as a programmer is using C sharp. Before that, I will work doing stuff in C sharp, also games with a framework called XNA. But it's been deprecated already, like for over a decade or something. But yeah, that's me. That's what I do. And today we're going to talk about AI. But as you were mentioning, sometimes software engineering, programming, AI sounds very complicated because it's very broad the term, right? Like we talk about the AI and it goes all the way from like the very basic mathematics and statistics to something like using an API that essentially does everything for us. And the thing that I found for myself and for other people is that it's hard to even know what to focus on, what to where to start, etc. So what I'm going to cover today is essentially how to talk with our data, with data that we already have, maybe in our database, maybe in some documents, maybe in some PowerPoints, etc., and how we can use natural language to interact with that data. We're going to use MongoDB, .NET, and C Sharp. I've been using Visual Studio, although I won't show my IDE, but I use Visual Studio Code. Before I was a big fan of regular Visual Studio. Then I discovered Writer and all the suite of products that they have. Then it became like very painful to have like Python, PyCharm and Writer and Sea Lion. So I came back to simplicity and I just used Visual Studio Code for everything, and I'm happy with that. But yeah, so that and also OpenAI. But everything that we talked about today, it can be swapped, right? Like if you want to use MongoDB for your database, or your database is not MongoDB, you can use whatever you want. You can replace the .NET C Sharp stack, or you can replace OpenAI, the GPT models that we'll be using here with Claude or Gemini or whatever you want. So this is just what I use. And Air Rack is this concept that's pretty popular, and also from my experience is what most people when they talk about creating AI systems, applications, etc. This is mostly what people talk about, and we're going to cover what Rack is in a second. So these are the goals for the session. Learn how to improve AI responses using retrieval augmented generation RAG. You might have seen this RAG all over the internet, on Reddit, on Twitter, etc. There are other like flavors of RAG, like graph RAG and visual graph, but essentially it's the same thing. We're going to implement a full rack stack using and full. Actually, I should have used an asterisk. There are things that we won't be implementing, but we will create something from beginning to end that we can talk to. MongoDB, .NET, and OpenAI. And the idea is that we have also some fun. I know it's gets honestly, I'm very impressed that noon on a Thursday we have how many people? 29 people joining to talk about coding. Like honestly, it's very impressive. So I hope you have fun. You learn something. I'm by no means expert on any of these things. I'm still learning. I sometimes I wonder like why did it take me so long to click some things on my head about this concept. So if I can save you some time of saying like, oh yeah, this guy mentioned something that now I understand without having to invest more time and on that, I will be very happy. So quick demo, and this demo works, but just for simplicity, I'm going to be showing screenshots of code and pseudocode. So yeah, if you copy and paste this on your IDE, it won't compile. But I promise you, this is a working demo. I have this on a GitHub repository. If you want, I can share it with you. It's not public because honestly, it's not scalable. It's just a demo. It's not a production ready app. But ideally, you get the idea of the components that you need to create this app. So what are we doing? And I didn't add a UI just to keep things simple. I was using Maui. Maui is the UI, right? But I started that in one computer where I had Visual Studio. Then I opened that on Visual Studio Code, and then I realized, oh no, this is getting more complicated than I was expecting. So I'm sticking to just the command line. But yeah, if you want, I think it makes more sense to completely build a UI interface and not asking like we're generating this advanced AI system, but then we're asking a person to use the terminal. I think it's counter intuitive, but I understand you all here are technical people and you understand that. So what are we doing here is we're generating this recommendation system that we can ask for recommendations of games. Now we could ask for video games. I mean, recommend me a game that was launched in 2005, and we could perform that with basic database queries. But in this case, we want the recommender system to give us more information based on context, based on things that are not really clear, right? In this case, I'm saying recommend me a game that is a shooter in space. Now, how will we be able to recommend this? Well, it gets trickier because usually like games don't say they don't have a field on Wikipedia that say, oh, where the game takes place, oh, in space. What if they say, oh, this game takes place in Mars? Then maybe the system won't know that Mars is in space. Maybe it will. We don't know. So we can add a question in natural language. We will understand the question, or the system will understand the question, and then it will generate a response also in natural language, saying like, okay, based on what you said, like you want a space shooter game, I can recommend you Halo Combat Evolved, and gives more information about who developed, who published, a bit of explanation of what is the game about, and it says also that there are other games that the player might enjoy, like Fortnite and Shadow of the Colossus, and it explains that these are not necessarily like space shooters, but maybe they will like them. Okay, so this is essentially what we're building. We're going to see how to tweak this response, how to search for the games or recommend that the LLM will recommend. But this is what we're building over here. Okay, so let's continue. And back to RAG and to this definition. And I think I'm not sure if we are software developers, engineers, computer scientists, sometimes we try to make things more complex or sound more complex just to have a mode on what we do, right? So if less people understand this stuff, then that means I will get hired more because yes, nobody knows that this is really very simple to use. So retrieval augmented generation, it's a very common technique just to essentially say an LLM such as ChatGPT can give information using data that it was not trained on. Like ChatGPT was trained on maybe Wikipedia, maybe was trained on the top websites on the internet. But what if you want this LLM to give information about your business in particular, about data that you only have in your PDFs that you use at your company, or your Excel sheets that you have in your company, or your your Word documents that only you have, then ChatGPT didn't have access to it. And what usually happens is it starts hallucinating. Another word, I think it's too fancy to just say, like, it just starts making things up, right? Like, if I ask, like, oh, how many employees inside MongoDB focus on this particular side of the business? Usually, ChatGPT won't know because it doesn't have access to that data. It will start making things up. And the problem is that it sounds very convincing, and that's one of the kind of like the dangers of these LLMs, that it sounds convincing, and then we believe, and we take that as truth. So this is just a fancy word to say that we're using custom knowledge, like domain specific knowledge or data that is just data that we just have, to extend the knowledge of the LLM. Can be GPT, can be Gemini, can be Claude, any large language model. Also here it says providing up to date information. If you have used, well, I guess it's the .NET meetup, we have to use Copilot, right? I haven't used Copilot, but I guess if you ask something, it will give you an answer saying like, okay, my cutoff date of data of training was November 2024. So anything that happens after November 2024, it doesn't know about that. So depending on what you're building, you may want to the LLM to be able to respond with newer data. So that's when you want to use RAG. And that's it. That's the whole explanation. You can replace RAG with making our LLM more knowledgeable with data that it was not trained on. Now, you might be wondering, if ChatGPT crawl the internet and they are training new versions of GPT all the time, why don't we just train or fine tune the model itself? It's another technique. The problem with fine tuning is that it's expensive. You need like beefy hardware, and gets expensive to train ChatGPT or to fine tune ChatGPT with your data. It's easier to use this approach. Um, yeah, and you have a bit more of control over the responses, and we'll see why. So, from a high level, this is the process that we need to follow to create a RAG application. We need to get data. In this case, we are scraping this data from Wikipedia or any other place that has information about video games in particular. We need to store the data. Usually, we need to store the data i- any regular database, but also we need to store data that's called vectors. And probably you've heard about vector databases, because for this use case, we need to perform some math on vectors, but it's actually we don't perform the math. The system will do that for us. So we just need to call an API, and that's it. We need to generate these embeddings. This is the process of generating these vectors. We're going to talk about that. We will perform a search. In this case, it's called a semantic search. So it won't search for a specific item in a database. It will search for related things in meaning, right? So as I was saying, if I ask for a game that takes place in space, well, maybe it will return games that are like simulators of colonies in Mars, but also will return games that happen, maybe racing games that happen on the moon, or I don't know, those things, because they are kind of related to the concept of space, kind of related to those things, but they are not one-to-one keyword matching. So we perform a semantic search, and then we provide a response to our user. And that's important too, because we, depending on what our system does, we want to tweak this response, what to say under certain circumstances, how to talk to the end user, how to yeah, essentially how it should behave with our users. So the first step is preparing the data. This is kind of like an optional step, because if you already have a database that's well structured, and that you know the schema and the relationship, the data is already prepared. But most of the internet, sorry, most of the data that businesses have, like internally, it's all over the place, right? Some teams might have like Word documents, some others might have like GitHub repositories with README, some others might have like PDFs with one format, with other format, etc. So it will be all over the place. And in this case, we need to scrape the data and provide some sort of formatting to the information that we're working on. It doesn't need to be only text. In this case, we're going to be using text, but it can be also images, audio, video, etc. The concepts here are essentially the same. We're just going to convert everything into a vector and then perform a distance search based on that. Okay, so what we need first for this scraping, I'm using this package HTML Agility Pack. I'm not sure if you've used it, but essentially it's just to format the information that we read from Wikipedia. So when we visit the Wikipedia page, we want to fetch like the game information, like the description, when it was released, who published the game, who developed the game, etc. But then we need to convert that into a more structured way. So we're using it here. I'm showing you an example using .NET just to be on brand with the meetup. But to be honest, I think even .NET users tend to do these type of things in Python, just because there are so many packages that allows us to handle data, format data, etc. But it is possible to achieve this with .NET for sure. Okay, now the web scraping. This is just an example of how it looks like. We visit each Wikipedia page based on the URLs that we're interested in. In this case, game sites. I manually told my scraper to visit, I think, 20 web entries of games that I know about, and then we just care about certain entries in the from the Wikipedia description. Essentially, the title, the image, the description. This description is the key to what we're doing here. We'll see why in a second. Who were the publishers? Who were the developers when it was released, and on which consoles they were released. Now, oh, sorry. Then it's preparing this data. So what we did before, it was just scraping the each entry on the Wikipedia page for each game. Now we went to store our data. For that, we're using the MongoDB driver for .NET. We have drivers for, I think, like 20 different languages, but in this case is the .NET driver. This is how I installed it in my project. You might be wondering why MongoDB. The first reason is because that's where I work at, and I get paid to say yes, use MongoDB. That's the main reason. But no, in all seriousness, it's because of the document model. If you're used to use SQL database, relational databases, I think it's good to have that structure, but the way these AI apps work and the way the data is changing and all at all times, it requires a lot of effort to constantly change our schema. So this document model, which is more flexible, allows us to, let's say today we know that our games have one publisher, but what happens if tomorrow we learn that, oh, some games have one publisher for the Americas, but then they have one for Asia and one for one console and one for PC, etc. So what do we do? In the document model, it's very easy to just add another element to the list of publishers that we have per game, and only for games that have more than one publisher. So that's one of the benefits. Of course, there are pros and cons, but this is why it's important here. MongoDB, in particular, in the cloud managed version that it's called MongoDB Atlas, comes with this feature called vector search, which allows us to perform this search in space based on how close or far are two points in space, two vectors in space. We're going to see that in a bit more detail in a second, but that's a feature that's key for these AI applications. Some databases don't have this built in, so you need to use your database, your operational database plus a vector database, and that's also okay if you want to do that. But in this case, everything lives on the same database, so you can perform your searches or some pre-filtering based on regular search and then vector search. And yeah, we have the driver for .NET and C Sharp. It's made by a team who just focuses on .NET technology. So it feels like you're at home. It's not like, oh, you need to adapt to another paradigm or anything, just to adapt. So we adapt to it. This is how we saved the data in Mongo. It's honestly pretty straightforward. It's since we don't need to create this schema beforehand from our client. We actually, as soon as we insert a new document, which is, think of a document as an entry in a row in a relational database, it will generate the schema kind of on the fly. There are techniques to allow you to have a more strict schema, but in our case, since this is like an evolving thing, we don't know like if the games are changing, if the there's a re-release that is the same game, but it's called the 20th anniversary edition, then maybe that's a different game. There are many things that are changing. So in this case, we won't make the schema more rigid. We want to keep it flexible, and yeah, pretty straightforward. I just get a client, I get the database and the collection. The collection is actually the list of all the games that I have in there, and then I will insert the game that I read from previously from Wikipedia. This is how it looks in Atlas. I'm using our custom, our cloud-hosted version. So these are all the documents that I added from my script. I hope it's not too small, but don't worry. Just believe that this text over here is actually the same information. Now, what I showed you before, this is how it looks. Each document, each entry in my collection looks like this. It has an ID, it has the title of the game, it has the image, it has the description, and as I was saying, for example, here it says the publisher is Rockstar Games, the developers are Rockstar North. For some reason, my formatting failed. So I should do some cleanup here, or not probably. I should do some cleanup here and remove this A. I don't know why that's a different publisher, a developer, and when it was released, the same thing. In this case, it says per console was released differently, and then the list of consoles. Now, for what we're doing, what we care about is actually the description of the game. And I just took like the first paragraphs of the description of the game, like it's an action adventure game. Who developed? Who published? What is it about? It was the 15th installment, for example. So you can start thinking about how our LLM, how our GPT or Copilot or Claude will be able to understand this and provide a recommendation. For example, let's say here it says something about street gangster, right? What if one of our users says, I want to play something where I play as the bad guy. Our LLM will be able to connect the ideas that, okay, the user wants to play as the bad guy, then, this is a street gangster called Franklin. So I will recommend this game, even if explicitly the user didn't ask for a street gangster game, a drug dealer game. I'm sorry for the bad example, or if it sounds very you know, uh, criminally, but GTA 6 it was delayed last week or 2 weeks ago. So this is my way to cope with the delay of the game. So, okay, so this is the game document. Remember, the description is what we care about and why we care about it. The next step is to generate what's called embeddings, another fancy term to just say convert one type of data into a numeric representation of that data, essentially a vector. A vector in the context here is just an array or a collection of floating point values that for us humans don't make any sense. When you see the vectors that these things generate, is just like values that look like noise that actually only the LLMs understand. And this is by design, just because of the complexity, but this is just the idea. So these embeddings are this numerical representation of data, as I was saying. So just a quick example of how this work, right? So imagine we have a triangle, a square, and a circle. These concepts, these are strings, not necessarily like a shape as we understand the geometric shape. So the triangle we convert that, we generate the embedding of the triangle and ends up with something like 0, 1, -1. Then the square, we generate the embedding on that word, and it generates something that 1, 0, -1, and the circle generates something like this. Now, what if we want to add a cube? And then we say, okay, where will this cube in space will end up at, right? Maybe our embedding model will say, well, the cube has four, it's closer to the square, so it will end up generating that vector somewhere closer to the square. Or maybe for some reason that embedding model says, oh, you know what? I saw something, maybe the color, maybe, well, not the color, because we're already talking about the words. Maybe the cube is closer to the circle for some reason because it uses more vocals, whatever. We really don't know what it is doing one to one. So that's the process of generating the embeddings. Now, I think if I was an embedding model, I would say that the cube will end up closer in space to the square, right? But there are more complex strings, like the full description of my game, that could be somewhere in a higher dimension. And this is I don't want to overcomplicate things, but just remember that these are vectors, and we're going to perform vector math on them, but we just ask how close or how far are you from 2 points. Well, we won't do this manually. Someone already invented these embedding models, and we don't need to do it. So that's just the general idea. So for the setup, we're using, and it shouldn't be pip here. It's actually, it shouldn't be. I remember why I left here, because there's no Voyage AI package for .NET. So this is just a note. Voyage is a company that generates embedding models for data, for text, that MongoDB acquired like 2 months ago. There's a Python package, there's a JavaScript or a TypeScript package, but there's no .NET. Now, what I did was to use the public API to generate these embeddings. Honestly, it's easier to do this in Python because I just use this package and generate the embedding, and that's it. But yeah, don't get confused. If you run this, your terminal will think you're crazy. Like, oh, why are you trying to install a Python package over here? But anyway, yeah, we're using these embedding models. You can use any embedding model that you want. OpenAI has its embedding models. There are Cohere, another company that generates these models. Just make sure that you use the same model to generate and to retrieve the embeddings. Otherwise, the results will be different. So just keep that in mind. And yeah, Voyage was acquired by Mongo. As I was saying, this is kind of the request that I'm using in C Sharp. The important thing here is that I'm using this Voyage model 3. This Voyage model 3 will take a string, and then it will return a vector of 1024 dimensions. That's what they call, but that's essentially the size of the array that we will get in return. Now, don't think of this as a regular vector in 3D space. It's just yeah, it's called an embedding. So it's just a value that will end up somewhere in a higher dimension space, but it's not 3D space. But again, don't worry. And I call the API, I will get the value, and then I will insert that into my MongoDB collection. Now, again, this is important because since we're using Mongo's flexible schema, at first, when I saved this information about the games, I didn't know I had the embedding value. In this case, what I'm going to do is for all the games that don't have the embedding uh, field in them, we're going to generate the embedding, and then we're going to add that field. There might be games that we don't want or don't need or something, and then we don't need to generate the embeddings. Maybe they're too old and we just have in database, but we don't need to compare them. We don't use them to recommend, etc. Then we don't need to add that field into the database. Okay, so that's it. What we have until now, we have data, we have the embeddings for our well, we have our embedding functions implementing on the description. So what I took was the description of my games, generated the embedding value, and then saving it into my collection again. That's what we have right now. Now, what we're going to do is to actually talk to this data. And remember, our example is a game recommendation system, but for you, it might be actually, the list of your employees and some information about them, etc., or your customers or your products, and you might want to ask, oh, what's the product that has the highest reviews or the most positive sentiment, not based on a ranking, but actually on the text of the descriptions or reviews by your customers. So this is the kind of like the entry point. This is the query that I asked for. Recommend me a game that's a shooter in space. I'm going to ask the question and then provide the answer. Now let's assemble that. Remember, we generated the embedding on all the descriptions of games. Now we're going to do the same, but for the question, for the query itself. And why are we doing this? To compare which games are closer to that question. Now, it's kind of difficult to understand what's going on because there's no easy way to just say like, oh yeah, this model is taking this word and then this word ends up on the index 5 of my embedding array. It's not like that. We really don't know. We really don't understand how that ends up. It's 2024, sorry, 1024 dimensions that we as humans, after 3 dimensions, we just stop understanding how these things work. Now imagine higher dimensions. It's very difficult. But anyway, what is going on is we generate on the question the embedding, and then we ask, okay, give me 3 games that are close in that space to the question, and then we return a response. So we do that. We perform a search. This is a vector search using MongoDB. For that, I need to create a vector index. In this case, since I'm using MongoDB Atlas, it's just a manual step in the backend. I'll show you that. But this is my vector index. This is what I'm using to tell the database that a particular field on my documents is the field that I'm using to perform the vector search. And then I return. I consider 100 candidates, so the closest 100 games that are closer to this, and then I can limit. I think it was to 3 the results that I want to recommend. But this is totally up to you to change. Then I generate my pipeline and I perform the search using that pipeline. This is how it looks on MongoDB Atlas. This is the number of dimensions. Now, this value, it's important when you generate it to be the same as the number of dimensions that our model uses. In our case, remember, we're using this Voyage AI Text 3 model. The documentation says that it uses 1024 dimensions, so we need to use the same value. Otherwise, it won't. It probably will. No, I don't think it will work. But well, you should test it and tell me if it works. I think the results will be strange and incorrect, but maybe it will compile and give you something. And then a similarity method. How do we want the vector search to be performed if we want to use, I think we support 3 or 4 similarity methods. There's this handy guide to help you pick the right method for considering your model, considering, I think, like the LLM and other things. But in this case, I'm using the cosine. And this is how it looks in text or in JSON format, but it's the same as I showed you. Okay, now to generate the response, I'm using GPT. I'm using the OpenAI LLM to generate the response. At this point, I haven't been using the LLM for anything. We just want to give a natural response. And this is how we're assembling that. So you can see here, this is, well, I'm I have these results from the games that I just read. So in this case, it gives me like three. Remember, we're requesting the top three closest games that our system found, and then we're going to compose our prompt. If you've used these LLMs, these ChatGPTs, etc., that's essentially how you interact with the LLM, right? You generate a trump. Look, I'm very stressed about the current situation. A prompt, not a Trump. We don't want to generate another Trump. At this prompt, and you say you can tell things like, okay, this is who you are. This is the query that you perform. These are the games that you found in the database. Then provide a recommendation that addresses the query, highlight why these games match to what the player is looking for, focus on this and this and this and this. But depending on what you're building, you might be able, or you might want to tweak this prompt to something like be more direct, right? Or if this recommendation system is for salespeople, then, you know, be more, give the person asking this like more tips on how to maybe close the sale and provide a tip of something that the user might like, or I don't know, you have more control about how you will give the response, or how the LLM will provide the response to your user, regardless of the actual games that it found and recommended. So yeah, this is a continuation. This is just the OpenAI API, how it works over here. We're using the GPT-4 model. OpenAI has a bunch of models. Usually you want to use like the latest model because it's going to be the smartest model usually, but you need to find the right balance between cost, because yeah, a bigger model or a newer model, it's probably going to use more it's going to cost you more money, and maybe you don't need to use a super smart state of the art model. You can use a smaller model for something like this. Actually, I think that GPT-4 is an overkill, but yeah, it didn't cost me anything to perform my test. But you know, if this was a live system, probably it will be cheaper to use another model. You can use models running locally on your machine, on your systems, etc. Some of these models are open source. GPT is not open source, but the Llama models by Meta are open. You can deploy them, or there are a bunch of services that allows you to do this. And this is how it works for GPT. Although I've seen other APIs working a similar way, which is like having this sort of chat system similar to ChatGPT, right? Like we create a new chat message where the role is the system. So this is what we're saying, telling our system to behave like, and this is the user message. So we send a prompt, we perform that, and then we return the response to the user. And that's it. That gives us a response. This is the very basic implementation of a RAG. Now, what are we missing here? Well, a couple of things. One is when we talked about generating our data, we assume that this information is either in our systems or in this case in Wikipedia or some other place. But what I've seen is most people, I don't know why, have their user manuals, some of their information in PDF files with different formats. So you need to, visit your PDFs, ideally programmatically, and chunk the information there, and then generate the embeddings on chunks of information in your PDF. So that's what the LLM, sorry, what your vector search performs the search on, not in entire pages, because it might be a lot. But usually there are some guidelines out there that say, okay, try to use chunking per paragraph, and then do some sort of overlap, so the search returns maybe not just one paragraph, but the previous and the the next paragraph. So the LLM has more context about what what's in that page. So it really depends on your use case. So before we go and before we ask some questions, some people have asked if RAG is dead, and they ask this because the context windows of LLMs are becoming larger and larger and larger. It will be possible to, every time someone asks something, to send them all our PDFs, right? And the LLM will be able to read the PDFs and give an answer. Now, it's possible because some of these LLMs have, or these models have huge context windows. The problem is that that's very costly to do. Also, you might be wondering, why don't we just retrain or distill the knowledge of our LLMs? The answer is that's also expensive, and the results so far are not as accurate as using RAG. But yeah, who knows? Maybe as we're speaking, or I haven't watched Google's keynote from yesterday. Maybe what I'm sharing today is already obsolete, and we just wasted 30 minutes of our time. So I hope not. But yeah, I don't think this is dead right now, or will be in the near future. Optimization. We didn't talk about optimization, but really depends on you. I think the first thing is to provide accurate answers, because if this LLM is not return, or your rack system doesn't return accurate systems, then it's worthless, or close to worthless. It's like generating a calculator that we don't know if the result will be accurate. So, will you use that? It's same for LLM, or a RAG application. But usually it's, as many things in software, a balance between execution speed, accuracy, cost. Some people are very concerned, and I think it makes sense about environmental impact of this, because it's very GPU intensive, etc. Remember that the data is not always structured and complete, and sadly, LLMs, and this is a problem, they're not good at saying I don't know. They will first try to make things up before saying, oh, I really don't know. So yeah, that we need some sort. And there are app services like Llama Index, LangChain, that allows you to benchmark and some sort of see how accurate your responses are being. If you want to know more, we have this GitHub repo with a lot of demos similar to what I showed you today. Most of them are JavaScript or Python, but you can get an idea of how to build different use cases, and to interact with a PDF, like what we did, but just to talk with like a PDF, etc. And there's this video, if you liked, or you want to learn more about the inners of how these LLMs work. There's this video that explains, I think, in 20 minutes how LLMs work, and I think it's worth it if you are interested, just so you understand like embeddings and the distance, how they're computed, and how these LLMs appear to be smart, but in reality, well, I will say they are smart, but it's just an illusion of this intelligence that they have. So thank you so much. Happy to answer any questions. Happy to also continue the conversation. Next time, I live in Austin. I forgot to mention, but I'm not there right now. But next time we have a meetup there, I would love to see other people, because I've been working from home for so many years that every time there's an opportunity to see human beings, I'm down to do that. So, and again, thank you for your time. I'm gonna
Awesome.
stop sharing.
Thanks, Arturo. Does
Thank you.
anyone have any questions? I
I
saw
do.
some activity in the chat.
Yeah, I mean, I think we have a few comments in the chat if you want to go over them, Arturo, or address them. Otherwise, if anyone has any questions, please.
Okay, ended up switching from Godot to Unity a few months ago. Okay. Avis, I think, yes, as David said, most people were doing the opposite.
I know some people were asking if they could find your slides somewhere.
Yeah, I can make them public, and I'm using one thing called slides.com, which is what I use, but I can make it public, and uh, yeah, I won't be able to concentrate and do the two things and put it in the chat, but I'll share them with you, Laura,
Yes.
and okay.
At the end, I'll share the recording and slides with everyone. No worries.
Okay. Oh, see, someone, yeah, Hakan found why the A was part of the publishers, and it's just because, yeah, it considered um the link closing tag as another publisher. Yeah, interesting. Oh, yeah, like a subscript A, actually. Cool. Will these slides be available? Yeah. Considering what you're getting back from the database, you could probably use a really basic LLM. Yes, yeah. I think for something like this, realistically, not even the GPT ones. Maybe there are some LLMs that run in JavaScript in the server that I think will be enough for what we were building over here. Yeah, and the 3D blue, one brown videos are great. So yeah, I think I answered the things that were here.
I will say I went through some of those three blue one brown videos pretty recently,
Oh,
and I
nice.
learned all the animations he has in those is a GitHub repo he wrote himself in Python. It's out there public. It's got like 30K stars or something for all those math animations. So he's
Nice.
like legit.
Yeah. It's it, I think it's Mark, his name, but he's like a modern genius or something. I
Yeah, like three blue, one brown. He has videos on like mathematics and calculus and stuff. Like if you were trying to learn anything in university for like the last 10 years that was math related, he basically had you.
yeah. Yeah, and the
Saw
anime.
someone put a question in the chat.
What are the limitations you've run into when talking to your chatbot? Such as how many space games are there on Xbox 360? Yeah, that's a good question. And in this case, for example, I think by default, what we have, if we ask how many space games are on Xbox 360, it will just use its training data. It won't use the data that we have unless the prompt specifically, but I didn't do this, says like only answer questions based using the results from the search that you performed. That's what it will be doing in this case. But yeah, that will be a limitation for our chatbot. We wouldn't have control over that answer. And I think just imagining it will use maybe someone on Reddit said like, oh, there are 100 games on Xbox 360, and it will give that answer. But in this case, it won't provide like an accurate response. We could extend it and say like, let's say our database has all the games that were released on Xbox. We could do something like a hybrid search, and say like count all the games on the database that has Xbox 360 as the release platform, give that answer to the LLM, and provide an answer using like a hybrid. But in this case, it's more of a regular search that will be converted to some sort of query language rather than a semantic search, as we did before.
Right, like in your demo, you're using the LLM to format the results in nice language, but the results are coming from your vector database.
Correct. Yes.
And how do you get from the user's query to the query you want to run against the vector database? Do you have?
Yeah, so the user query, the question, we generate the embedding. So we generate that vector, and then we tell MongoDB like, give me the 3 games that are closer to this question, like whatever that number is, and then it will
Mhm.
find us. Yeah,
Close
yeah.
to- yeah.
So yeah, it sounds sometimes like magical because there's no easy way to visualize these things, but somehow they work, and this is the interesting part. But yeah, that's how it works here.
I have a question. So you're generating 1024 dimensions in that you're storing in your vector database, and you said that has to match with I assume the LLM. But when you query, so there are two inputs, right? There's scraping the data and then storing that. So you have to use the same model that interpret the scraped data as you ask the question, right? Because otherwise those, even if it's a, you know, a 1024 array of numbers, the meaning can be different if it's different model. Is that a correct understanding?
Yeah, correct. Usually the models have the similar dimensions, but the depending on the model that you're using to generate the embeddings, even when they share the dimensions, they will have different meanings.
Oh,
So
okay.
yeah, why it's
So it has to be
important.
the same.
Yeah.
Yeah,
It has
that
to
makes
be
sense. Okay, I just want to confirm that. Thank you.
Yeah. No, thank you. So I'm gonna share the. I'm gonna paste the slide deck. It should be public, I think.
Don't want to put you on the spot here, Arturo, but if anyone has like any other questions or more specific, anywhere they can reach you for that.
Yeah, absolutely. You can reach out to me over email, arturo.nunes@mongodb.com, or Twitter. I'm still very active, sadly, on Twitter.
Okay.
But yeah, or LinkedIn also. Yeah.
Yeah, just because I see here like someone asking like a list of steps for setup. Maybe we can cover it here on the questions, but maybe they can reach out to you for anything further, right?
Yeah, absolutely. And also I can share with you something that I was working on. Maybe it's useful. It's kind of like a shameless plug, is
Say
that called?
Arturo also has 4,000 followers on Twitter, so
Oh,
he's internet famous. Yeah.
no, well, I'm more proud of these 87 stars on this GitHub repository.
It's pretty cool, dude.
I've been putting together throughout the past 5 years a list of all the materials I've been using
I
to
love it.
try to learn. I'm not an expert, and I actually feel bad because there's no way I've read all these things, and still sometimes I'm like, I don't understand this thing. But if it's useful for someone, it has books, papers, videos, tutorials, a bunch of things that I've used to learn. So I'm going to put it on
Can
the
you put
chat.
that link in the chat?
Yeah, absolutely.
That'd be awesome.
And I try to add some descriptions to those things just so you can see like, oh yeah, this is more related to what I want to learn. Because as I said at the beginning, you can go in the rabbit hole of just learning the maths for deep learning, and then realizing like, no, well, this is what happened to me. Like, there's no way I'm going to build my own models. I don't want to do that. It's interesting, but no, this is not for me. And then you go to the other side, which is maybe more high level, where it's like, okay, yeah, also I don't just want to use ChatGPT and be a wrapper for ChatGPT, right? So yeah, that's kind of like what I've been doing. But yeah, also GitHub. If I don't think anyone uses, I don't even think GitHub has a messaging system. But yeah, that's another way to.
Yeah, and guys, just so you know, we're also share the chat recorded here on the meeting with you, so no worries about keeping those links. we'll get them to you.
Yep. All right. We are 1 minute over, so I think it's pretty good timing. Thanks everyone for the questions. Thank you, Arturo, for awesome presentation.